Hello and welcome to the course of network security. In today's lecture, I will talk about symmetric, or which is also known as private key cryptography or encryption and decryption. The contents for today's presentation is that first I will explain what symmetric encryption is, and then the major components of symmetric encryption, where we can use symmetric encryption, what are the requirements and different types of symmetric encryption. Let us see what symmetric encryption is. The symmetric encryption is also known as conventional encryption, or you can say private key encryption, secret key encryption, or sometimes single key encryption. Different names are there to refer to the symmetric key encryption. Before the invent of public key encryption in 1970, this was the only type of encryption available to the community. In very simple word, in symmetric key encryption, we use a single key for both encryption and decryption, or you can say that the sender and receiver both have to share a common key, and the shared key must be known only to the participants, not to the third parties. If either key of if for example a copy of that key falls into the wrong hands, then messages or your communication can be decrypted by other parties, and even the sender and intended receiver may not know that the message was intercepted by someone in between. The primary challenge of symmetric key encryption is getting the key to the receiver, a process that must be conducted out of band to avoid interception. In other words, the process must use a channel or band other than the one carrying the ciphertext. You have to use a different channel for sending the key, and that is the secret, and it must be known only to the sender and the receiver. Some examples of algorithms which depend on symmetric key encryption are DES algorithm, data encryption standard, S algorithm, advanced encryption standard algorithm. Both these algorithms are based on symmetric encryption. Let us see how we can graphically represent this symmetric key encryption. Here you can see that we have a sender and receiver, and they want to communicate securely with one another with the help of symmetric key encryption or with the help of private key encryption. Let's suppose this Rachel is working at ABC company, generate a secret key. She must somehow get it to the Alex, who is the intended receiver, and he is working at XYZ company. Once Alex has the key, then Rachel can use it to encrypt messages, and then Alex would be used to decrypt the messages. Mean uh, to they need to access this key in order to encrypt and decrypt messages. For example, the message sent by Rachel is the deal is a go. She must encrypt this message with the secret key. For example, the key is represented by A. So she will use the key to encrypt the message or to convert it into ciphertext. And then on the receiver side, the Alex will use the same key represented by A to derive the plain text from the ciphertext. So in this case, you can see we are using the same key that is represented by A for encryption and for decryption. And such type of encryption is known as symmetric encryption. Like we studied in the previous week, there are different components of cryptography. Same is the case with symmetric encryption, as it is a type of cryptography, so the components are almost the same. We need a plain text, which is the original message. We need the ciphertext, which is the encrypted message. We need the secret key, which must be known to both the sender and receiver. And this key is also work as an input to the encryption algorithm. The sender uses the key to encrypt the plain text and send the ciphertext to the receiver, while the receiver will apply the same key to decrypt the message and recover the plain text. We also need encryption algorithm, and the encryption algorithm performs various substitution and transformation on the plain text. It takes the plain text and the secret key and produces the ciphertext, and it works on the sender side. On the receiver side, we will need the decryption algorithm. It is essential that the decryption algorithm works in a reverse fashion. Like in the encryption algorithm, we convert plain text into ciphertext, while here in the decryption algorithm, we will actually convert the ciphertext into plain text. Here is how the different components work together. We have a sender and we have a receiver, and we are using a shared secret key. So first we need to convert the plain text. For that we need the encryption algorithm as well as the key. The key is used both for encryption and decryption of the message. The same key is actually used. After converting the plain text into ciphertext, we send the ciphertext on an unsecured medium, and then on the receiver side, the receiver will use the same key and the decryption algorithm to derive the plain text from this ciphertext. Some uses of symmetric key encryption, we can use them in different areas. Some of them are like secure storage on insecure medium. If you want to store the file in an encrypted form, then you can use secret key cryptography for that purpose. We will not go into the details about this topic, as these topics are going to be covered in the coming weeks. But let me give you a brief overview. We can also use it for transmitting over an insecure medium, and this is the most primary use of symmetric key encryption. We can send messages on a medium that can be taped without worrying about the eavesdroppers. An eavesdropper will only see ununderstandable data. And we can also use it for authentication purposes. Strong authentication is possible with the help of secret key encryption. It is particularly useful when two computers are trying to communicate over the insecure medium. And you can also use it for integrity check. In integrity check, we actually use a checksum. Checksum protects against accidental corruption of a message, but we will study about checksum integrity checks later on in this course. Now let us move towards the requirement for symmetric encryption. There are two basic requirements for the symmetric encryption to work properly. The first requirement is that we need a strong encryption algorithm. At a minimum, we would like the algorithm to be such that an opponent who knows the algorithm and has access to the cipher text would be unable to decrypt or decipher the information, or you can say derive the plain text from the cipher text. Or you can say that he or she would not be able to figure out the key from the plain text, from the cipher text. And if he or she knows the algorithm, which means that your algorithm must be secure. Not secure in the sense that you have to keep it private. Remember, the algorithm must be public. People know which algorithm you are using for encryption, but they would not be able to derive the key or the plain text from this information. So you must use a strong encryption algorithm. The second requirement is about the key. The first requirement is about the algorithm. In short, it must be secure, strong. The second requirement is about the key. Sender and receiver must have obtained copies of the secret key in some secure way, secure fashion, and they must keep the key secure. If someone can discover the key and knows the algorithm, all communication using the key is readable. We assume that it is impractical to decrypt a message on the basis of the ciphertext plus knowledge of the algorithm, as I just mentioned. Without the key, nobody is able to decrypt the message. Okay, but for that the key must be securely shared between sender and receiver. We can use key distribution center for that purpose, or another band or channel for making the keys available to both the parties. Okay, there are two types of symmetric encryption. One is known as block cipher and the second one is known as stream cipher. Let us see what is a block cipher. Block cipher, as the name indicates, it actually operates on block of plain text and block of ciphertext. Normally the block size is fixed, and the block of ciphertext produced by a block cipher is usually the same length as the plain text block. It processes the input one block at a time. and it produce output one block at a time. For the each input block, it will produce an output block. The concept is like that. Or you can say that the algorithm selects a block of plain text bits, perform a series of operations on them. Operations mean to convert them into ciphertext. And then it outputs a block of ciphertext bits. A block cipher may be considered as two related functions, encryption and decryption, each of which takes two input. The input to the encryption function are the plaintext block and a key. The input to the decryption function are the ciphertext block and the same key. Same key because we are using symmetric key encryption algorithm. And the basic idea is shown here. We have the plain text, we divide it into blocks. Here you can see two blocks, and then we apply the encryption algorithm. And then it produces a block of ciphertext, and then we combine the block of ciphertext. Some of the important algorithms that make use of block cipher are DES algorithm, triple DES algorithm, and advanced encryption standard algorithm. Let us see what is a stream cipher. A stream cipher is another very useful class of cipher. It is important class of symmetric key encryption scheme because stream cipher operate on streams of plain text and ciphertext instead of operating on blocks. A typical stream cipher encrypt plain text 1 byte at a time, or in some cases a single bit at a time, or maybe more than 1 byte at a time, right? So it encrypts bit individually by adding a bit from a key to the plain text bit, 1 bit from plain text and 1 bit from the key, encrypted. These cipher have the advantage of not having to wait for the entire block to become available before encryption. This is the advantage. They do not need to wait for the whole block. And with the stream cipher, the same plain text bit or byte will be encrypted to a different bit or byte every time it is encrypted, because every time we are considering single bits from the keys and from the plain text. So maybe it is possible that the same letter is encrypted to a different ciphertext, which means more security. Okay. Final words about this cipher is that in practice, in particularly for encrypting computer communication on the internet, which is insecure, block cipher are used more often as compared to the stream cipher. Why? Because stream cipher tend to be small and fast. They are particularly relevant for application with little computational resources like cell phones or other embedded devices. But for internet, mostly we use the block cipher. Thank you so much for watching the lecture. Goodbye.